Okay, so today we're going to be talking about systems of quadratic equations. So if you remember from, hold on. I'm sorry, already struggling. Okay, sorry. All right, so if you remember from before when we had systems of equations, we had like a line like this and a line like this, and the answer to these is where those two lines crossed. Okay, that it's the exact same way on whenever we're doing quadratics. So what is the solution of the system of equations? And it is where the lines cross. So there's a few different ways to solve these. One way is by graphing. So let's go ahead and graph it. Looks like we have a parabola. This is going to bother me, it's crooked. There. Okay, so we have a parabola. That's a sad face parabola because there's a negative out front, and then a line. Let's do the easy one first and graph the line. So you have x plus 3, so your y-intercept is positive 3. And your slope is 1, so up 1, over 1 in both directions. I don't get to record videos on Notability. I do it on Explain Everything, and it doesn't draw the lines quite so pretty. I have to draw them, that's why they're not so pretty. All right, you guys get the idea. That's a straight line, right? Straight enough. Okay, so now let's do the parabola. I know you forgot all about how to graph a parabola, but don't worry, I'm going to remind you. First, we need to find the axis of symmetry. Remember, it's negative b over 2a. So this will be negative 1 over 2 times negative 1. Okay, and so this would be positive 1, and that would be positive 2, or negative 2, sorry. So your axis of symmetry is x equals negative 1/2. Okay, so that would be right here, negative 1/2, and it's going to be a vertical line that looks something like this. This is my axis of symmetry, so we know it's symmetrical around there. Okay, another point that we know right off the bat, this, remember, is your C is your y-intercept. So, I got to finish the vertex. I digress. Okay, well, we'll put the y-intercept in. So the y-intercept is 6. Okay, let's go back to the vertex. So now we have to plug in 1/2 into our original equation. So this will be negative 1/2 squared minus 1/2 plus 6. When you put all that in a calculator, you get 6 1/4. Okay, so your vertex of this parabola is at negative 1/2, and then 6 1/4. So that would be about right here. Okay, so we've got part of our parabola. So now let's see which points for our x value should I pick, because we're going to do the old-fashioned way and plug it into a table. And the reason I am plugging it into a table is because my vertex is 2 fractions and it's just kind of a mess. So we're going to plug it in using make a table and plot the points. So I'm going to pick the point 1, 2. I already have 0 and negative 1, so let's do negative 2 and negative 3. So let's pick those points. So I said whenever we have x and y, so let's do negative 3, negative 2, 1, and 2. Okay, so when I plug in negative 3, I'm going to save some time. I've already worked it out in the calculator. You get 0. And when I plug in negative 2, and remember, I'm plugging it into the original equation just like I plugged that 1/2 in. So this, I just realized it's a negative 1/2. But that's okay. I already did the math. The math is correct. Okay, so anyway, plug in your negative 2. I already did it, so you get 4. Let's plug in 1 and you get 4, and plug in 2 and you get 0. Like I said, I already did this math, that's why I knew it. Okay, so the first point was at negative 3, 0. Hey, look at that. That's a good sign. The next point was at negative 2, 4. And 1, what was it? 1, 4. So 1, 4, oh, looky there. And then 2, 0. Okay, so this looks symmetrical over the axis of symmetry, which is good. Oh, look at that good looking parabola. Okay, so our answer to this equation, remember it's the solution where it crosses, and this time it crosses twice. So it is this point and this point. So our solution for this system of equations is the point negative 3, 0, and then the point 1, 4. So those are our solutions. Okay, that was a lot of work. Can you solve this algebraically? Yes, and that's how I'm going to solve this, most of these, all of these, the rest of them. So first, let's talk about something. I really need to get better about my videos. That's okay. So if you have, this is me going off track a little bit. So if I have 2 plus 3, that equals 5. And 1 plus 4 equals 5, then you could say 2 plus 3 equals 1 plus 4, right? I don't know if you remember your geometry properties, but that's the transitive property. Okay, so now let's say I have another one, something else. I have 1 plus 2 equals y, and 3 plus 0 equals y. So we could say y equals y, or we could say 1 plus 2 equals 3 plus 0, right? You can say either one of these from those two statements. Okay, as you notice, in these two equations, they both equal y. So since y is the same, we can set this piece equal to this piece, because y does equal y. So let's do that. So we're going to have negative x squared minus x plus 6 is going to equal x plus 3. All right, now, how would you solve this? This is going to be a trinomial. That's okay. We're going to either solve by factoring or the quadratic formula, or I don't think we can complete the square on this one, so this one is solved by factoring. I think it's the easiest. So I'm going to subtract x, subtract 3 to get everything over on one side and a 0 on the right side, because remember you need that. So this would be negative x squared minus 2x plus 3 equals 0. Okay, so now I need what adds to be negative 2 and multiplies to be negative 1 times 3, so negative 3. That means I need a positive and a negative, and my bigger number needs to be negative. So that would be what? Negative 3 times 1? Negative 3 plus 1? Yep. So we're going to have to factor by grouping. So this would be negative x squared minus 3x plus 1x plus 3 equals 0. You could have wrote it the other way. That's already committed. So we have this. This factor out a negative x. This would be x plus 3. On this one, factor out just a positive 1, so that doesn't change it at all. So it'd be x plus 3. So now I have negative x plus 1 times x plus 3 equals 0. Set each piece equal to 1. So you have negative x, sorry, I didn't even put those parentheses. Negative x plus 1 equals 0, and x plus 3 equals 0. So let's add x, so 1 equals x. Subtract 3, so x equals negative 3. So my answer is 1 and negative 3, right? Wrong. Okay, so if you remember, we're looking for an ordered pair. Do you notice that the 1 is the x value there, and the negative 3 is the x value here. There is a relationship. So after you solve for both x's, you plug, let's write this down. So let's write step 1, solve for x. Okay, step 2 is to plug in both x's to one of the equation and solve. Okay, so it doesn't matter which one, pick the simplest one. That's what I'm going to do. Which one do you think is the simplest one? The bottom one, the one right here, right? It only has 2 terms on the right, and there's no squares, nothing too crazy. So I'm going to have the equation y equals x plus 3, and I'm going to plug in 1 and negative 3 in here. So when I have y equals 1 plus 3, that gives me y equals 4. So that coordinate would be 1 for my x and 4 for my y. The second one, I'm going to be plugging in negative 3. So y equals negative 3 plus 3, so y equals 0. So that coordinate is negative 3, 0. Look at that. I'm a wizard. We got the exact same answers. So right here and right there, there, and there. Okay? So you can get the exact same answer algebraically or graphically. If you have a graphing calculator that you're allowed to use on a test, which you're not on this test, but if you are, just plug it into a graphing calculator and figure out where they meet. That's the easiest way if you're taking the ACT. But on this test, you are going to have to know how to solve it algebraically. Okay? Let's do the next one. Okay, so this time we have 2 quadratics, which is fine. Let's go ahead and let's go ahead and set the equations up to equal each other because they both equal y, so we can set them equal to each other. So this will be x squared minus 4x plus 5 equals negative x squared plus 5. Okay, get everything over to one side. So I'm going to add x squared and subtract 5. Okay. So this equals 2x squared minus 4x plus 0, those cancel out, equals 0. Okay, what's the best way to solve this? You could use the quadratic formula. On this one, again, I think factoring is the easier way to do it. So on this one, it's not a trinomial, so we're just going to factor out the GCF. So that would be 2x is my GCF. So that would give me x minus 2 equals 0. Okay, now set each piece equal to 0. So I'll have 2x equals 0 and x minus 2 equals 0. Divide by 2, so x equals 0, and add 2, so x equals 2 and 0. Okay, sweet, we got the first part done. Now we need to plug it into one of the original equations. Does it matter which one? Nope, but I'm going to plug it in this one because it only has 2 terms. So if I have, I'm going to rewrite the equation, y equals negative x squared plus 5. So I'm going to plug in when y equals 0. This one will be easy. 0 squared plus 5. So your y value for this one would be 5. So your coordinate would be at 0, your x value you found earlier, and the y coordinate 5. All right, the other y coordinate we have to plug in is 2. So this would be 2 squared, oh, there is a negative sign, so that should be negative. Negative 2 squared plus 5. Order of operations say you have to square it and then slap the negative on there. So that would be like 4 times negative would be negative 4 plus 5 would give you positive 1. So your y is positive 1. Don't believe me? Put it in a calculator, see what you get. So your x coordinate was 2, your y coordinate was 1. Looky there, we have our 2 answers. Done. All right, next one. Oops. Okay, so Actually, this is the exact same problem. I'm sorry, I messed up. Let's change this. And we're going to make it y equals x squared minus 3x minus 2. And the second one is going to be y equals negative x squared, plus 4x plus 2. So that's the second equation. All right, set them equal to each other. We have two trinomials. Oh no, what are we going to do? Math. So this will be x squared minus 3x minus 2 equals negative x squared plus 4x plus 2. Okay, so let's go ahead. So let's move everything over. I'm going to write it in different colors. So let's add x squared, subtract 4x, subtract 2. No, you don't have to write this out, but I do because I'll probably make a mistake if I don't. So this would give me 2x squared minus 7x minus 4 equals 0. Okay, again, we could solve by using the quadratic formula. You know what? Let's do something different. Let's solve by using the quadratic formula, just because I want to sing the song. So x equals negative b, so negative 7 plus or minus the square root of your b term squared, so negative 7 squared, minus 4 times your a times your c all over 2 times your a. Okay, so let's simplify it up a little bit. So this would be positive 7 plus or minus the square root of 81. Look how nicely that turns out, over 4. So this will be 7 plus or minus 9. Just do this and make it 9 over 4. So 7 plus 9 would be 16. 16 divided by 4 would be 4. So x equals 4. And the other one would be 7 minus 9 would be negative 2 over 4. So x would equal negative 1/2. Okay, sweet. So we've got our two x's. What did step 2 tell us to do? Well, you have to plug those into one of the original equations. Doesn't matter which one. They're both kind of gross. I'm going to pick the top equation just because it doesn't have a negative out front. So use your calculator on this. So let's see. I'm going to have, let's do the 4 first. So 4 squared minus 3 times 4 minus 2. And that would give me the 2 whenever you plug it in your calculator. So this point is at 4, 2. The next one, definitely use a calculator on this one, negative 1/2 squared minus 3 times negative 1/2 minus 2. Oh, that's pretty gross. Oh, look, we get a fraction. It's negative 1/4. So that this coordinate would be at negative 1/2, comma, negative 1/4. So those are the two solutions to that problem. Okay, we've got, now let's move on to something a little bit different, but pretty much the same. So do you remember whenever we had systems of inequalities? So if I had a graph and I did a line like this that was solid and I shaded below it, and I had a line that was dashed that looked like that and I shaded below that one, then this area right here that was shaded by both of the inequalities was my solution. So this is the exact same thing. What is the solution to the system of inequalities? So remember, this is not going to be an exact point, it's going to be a region, so that's why we have to have a graph. So let's first graph the top one. It's going to be a sad face graph. Let's find the vertex, so negative b over 2a. Oh, one more thing, let's change this 9 to a negative 6. So instead of negative 6 or negative 9, it's a negative 6. So we're going to have negative 6 over 2 times negative 1. Excuse me, negative 6. So it would be positive 6 over negative 2, which would give me negative 3. All right, plug that back in. So that would be negative times negative 3 squared minus 6 times negative 3 minus 2. And when you plug that in your calculator, you get 7. So your vertex is at negative 3, 7. Let's go ahead and plot that. So negative 3, 7 would be right here. That's also your axis of symmetry is at x equals negative 3. The y-intercept, remember this is your y-intercept, is negative 2. So this would be negative 2 right here. And instead of making a table and plotting the points, I'm just going to do the other side of the axis of symmetry at negative 2. And it will be right about here. Oh, nope, that's not right. It'll be one more over, 3 away. Okay, so now I have my graph. Okay, oh my gosh, gotta try it again. I was doing so good. Okay, that's ugly, but we're gonna go with it. So there's our graph, and now let's look. It's y is less than that, so that means we're going to be shading below. So less than, remember, is below. So we're going to be shading all of this beautiful area right here. Okay, now let's do the other one. Y is greater than x squared minus 2. Since this one is already pretty much in vertex form, remember this vertex, oops, so this vertex would be at 0, negative 2, because remember it's y equals x minus h squared plus k. So my h is 0 because there's nothing with that x squared, and my k is negative 2. So my vertex is at 0, negative 2. So 0, negative 2. All right, and now does this have a shrink or a stretch? Is there any number in front of my x squared? No, it's not. So it's your traditional over 1, up 1, over 2, up 4, over 3, up 9, and so on. So over 1, up 1 in both directions, over 2, up 4, and then let's be extra and do over 3, up 9. I'll be right there. Okay, oh look, this really overlaps. Okay, so here is my parabola. In what direction are we going to be shading? Well, it's y is greater than, so we're going to be shading above. So let's do that. Try not to color outside the lines over there on the left. So as you can see, this little area that is covered on both of them is our region that satisfies this solution of inequalities. So that means that I could pick any point in this region and it would be a solution for both of those inequalities. Okay, one more. This one, last problem. We have, let's find our axis of symmetry. So negative b over 2a, so that'd be negative 4 over 2 times negative 1. And negative 4 over negative 2 would give me positive 2. All right, plug that in. Negative times 2 squared plus 4 times 2 plus 3 would give me 7. Okay, so my vertex is at 2, 7 for the top one. So vertex is at 2, 7 would be right here. And then my axis, or my y-intercept is 3, so let's just do that. Y-intercept is 3, and then let's go to the other side, do 3 right there. Okay, so now we have our parabola. Okay, I'm going to leave that even though it's ugly over there on the right side. Okay, now let's graph the other one. Oh wait, we forgot to shade. All right, I forgot to show. It is, oh, I just realized something. These lines, you probably already noticed, should be, I'm not going to redo it because I'm in a hurry today. But these lines should be dashed lines on both of these. So hopefully you caught that already, but if not, it's okay. It's my fault too. So both of these, whoa, should be dashed lines. Okay. Going down to here, the first one should be solid. The second one should be dashed. So good thing I've already drew my solid line. I don't have to erase it. Now let's do the dashed line. So we have our vertex for that second one. Remember, it's already in vertex form. Is going to be at 0, +3. So 0, +3 would be right there. It's a dashed line. Does it have, it's a happy face because it's positive out front. Does it shift, or does it have any shrink or stretch? No. So over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. And this is going to be a dashed line. This is going to be crazy. Hey, that's not bad. Maybe I should make all of them dashed. I'll draw them prettier. And I realized we just forgot to shade, so I got distracted. Let's shade the blue one first. So y is greater than x squared plus 3. Let's go ahead and shade this. So it would be all of this area right here. And then the other one, y is less than or equal to all of that stuff. So less than, we're going to shade below it. So it would be all of this right here. So that little bitty area right there is the only part that satisfies both inequalities. Okay, I'm sorry this lesson took so long. I hope you enjoyed watching and you didn't make fun of me too much. I hope you have a great day. Bye.